Similar to character-based framing, which was used for transmitting alphanumeric or ASCII-based characters, we see that in modern times, we are interested in sending binary data that could be images, video, or web data. For that, bit-oriented framing is the standard. In this module, we shall understand the rationale for using bit-oriented framing. We'll look at a special 8-bit representation called flag, and then we'd also look at an example. Bit-oriented framing with regards to framing with and without error control is discussed in Bertsicus and Gallagher. Bit-oriented protocols are meant for synchronous communication for variable length frames, and the examples include voice, image, and web data. This bit-oriented synchronous protocols can then be used on dedicated or switched networks, simplex, half duplex, or full duplex networks. Bit-oriented framing is based on the concept of 8-bit representation called flag. This flag appears before the start and end of the user data and other control information. Now, this could appear as well in the payload like character-based framing. In order to avoid such situation, a certain procedure is adopted. That is, when the data link layer detects contiguous sequence of 5 ones in a row, in order to prevent the 6th one and a 0 appearing, that could possibly lead to a problem because it could be the start or end of a frame in bit-oriented framing. A 0 is stopped immediately after the 5th one in the transmitted stream. Since this has been a deliberate activity and this is not part of the data itself, the data link layer at receiver removes additional or inserted zeros in the payload by looking for contiguous 5 ones followed by stuffed zeros. The problem gets solved because if there were any confusion between possible appearances of the flag within the frame and the actual delimiting flags for the start and end, the confusion is now handled. Let's look at an example. Here you see that we have an input stream, then we stuff zeros in there, and then we unstuff them on the receiver side. The conclusion is the frame after stuffing never contains more than 5 consecutive ones. Hence, the flag at the end of the frame is uniquely recognizable.